Hello everyone, welcome to our presentation about analysis of different machine learning architecture for pattern recognition in industrial Internet of Things. As we enter the Industry 4.0 era, more and more data are collected by sensors. However, this data can be very different as they are across different production lines, so analyzing them could be very difficult. However, new ideas like the artificial intelligence and machine learning may offer potential help. The most basic architectures in machine learning is the multi-layer perceptron. It has an input layer and one or more hidden layers. In these hidden layers, the neurons will be connected to adjustable weights, and by using activation functions, the data can be converted into fixed length windows to indicate patterns. And in the upper layer, you can convert these neural symbols into computational symbols. However, there are also situations when we need to deal with image data. In this situation, the data is no longer fixed length, so we need the new architectures like convolutional neural network. The convolutional, it has two major layers, the convolutional layer and the pooling layer. In the convolutional layer, we will decompose the high resolution images into smaller parts, and the pooling layers will be addressed for the original position of the smaller images from its original one. With multiple runs of these two layers, we could move into more complex and sophisticated layers that convert these image data into operational symbols. Unlike the convolutional neural network, the recurrent neural network will be more focused on the time sequence of data. It will capture the temporal dynamics and data dependency over the time sequence by feeding back the output from previous stages to show how history relevance of these data. In this way, it will be more accurate. However, we could see these major architectures all have its disadvantages. For example, the MLP and RNN cannot address images, while the CNN cannot give a clear reason about the data time sequence, thereby lowering its data accuracy. So the solution is the hybrid architecture. It combines the architecture of CNN and RNN. In this way, it will be way more accurate than any of these single layers. And at the same time, it also could be tailor-made to suit more image data or data more related to time sequence. However, this architecture is also hard to train, and it requires a lot of computational power, and it is also very hard to design. So in conclusion, different models suit different situations according to the data priorities and system performance. While hybrid architecture seem to be the best solutions for different situations, but they also face issues. So future studies could focus on how to make the best use of limited computational power to achieve higher data accuracy and reliability, and also address the issues related to limited data resources. That's all for this presentation. Thank you, and here is the reference list.